Sample exam 6, part 6, problem number 43. A random sample x of size 1 is taken from a distribution with density function f of x, which is equal to lambda e to the minus lambda x. Suppose the null hypothesis that lambda is equal to 1 is to be tested against the alternative hypothesis that lambda is between 0 and 1. If the null hypothesis is rejected whenever x is greater than the natural log of 10, then what is the power for this test for any lambda between 0 and 1? Problem number 43, we're asked to find the power of this test. And the power is when the alternative is true. And you have to pick a specific value for lambda in the alternative region. So we're just going to call that generically lambda, and that's between 0 and 1. And we want to find the probability that x is greater than log 10 under the null hypothesis. So we integrate from log 10 to infinity of our density, and we plug in this lambda here. We integrate, we get this, we plug in our limits of integration, we get e to the minus lambda log 10, but this can be taken to the top of this and the e and the log cancel, and we get 10 raised to the minus lambda. Number 44, if a fair coin is tossed repeatedly, what is the probability that the third head occurs on the nth toss? Number 44, we're asked to find the probability that the third head occurs on the nth toss. So here's a little diagram, and if the line represents n tosses, where this last little piece represents one toss, and it's the third head. And what that means is that there has to be two heads in the first n minus 1 cases. Well, flipping a coin is a binomial, and this is n minus 1 chances, and we want two heads. So if you just look at this piece here, that's a binomial n choose 2, because we want 2 of the n minus 1 to be heads. Probably the head is a half, so it's 2, probably a tail, and there's going to be that many tails. And the last one is going to be one, it's going to be a head, and probably that is a half. So now we combine this, and this to here. So it's 1/2 to the n, and we have n minus 1 choose 2. Well, this is combinatorics, which is this. Well, it's n factorial divided by 2 factorial divided by n minus 3 factorial. Anyway, so you get some cancellations, and this 2 can be taken into the 1/2. So it's 1/2 to the n plus 1, and then the numerator stays the same, and that's the answer. Number 45. Let x have a Poisson distribution with parameter lambda equal to 1. What is the probability that x is greater than 2 given that x is less than or equal to 4? So problem number 45, we want to find the probability that x is greater than 2 given that x is less than 4. We're also given that it is a Poisson distribution with lambda parameter 1. And then that's this, and then that reduces to this. So that's our probably mass function. And the probability that x is greater than 2, x less than 4, it can be rearranged to this, so that x, it's the intersection of these two, which is this, so x is between 2 and 4, and divided by the probability that x is less than 4. So we're going to work on this in pieces. We're going to do the numerator first, and the probability that x is greater, between 2 and 4, so you plug in for x here, 2, and then 3, then 4, and I factor out a e to the minus 1, and then you get 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial. That combines to 17/24. Now the denominator, probably that x is less than 4, That means 0, 1, 2, 3, 4. So we plug in 0, 1, 2, 3, 4 to our probably mass function, factor out a minus half, add the rest, we get this. So then the probability becomes the division of this and this, which is this. So the e to the minuses ones cancel, and then this reduces to 17 over 65. Number 46, if R.A. Fisher proved that when n is greater than 30 and y has a chi-square distribution with n degrees of freedom, then 2y raised to the half minus 2n minus 1 raised to the half has an approximate standard normal distribution. Under this approximation, the 90th percentile of y when n is equal to 41 is closest to. So problem number 46, we're asked to find the 90th percentile of y. Okay, before we start, the 90th percentile of a standard normal distribution is 1.28. So this, it said this piece here follows a standard normal distribution. And we want to find the 90th percentile of y based upon that knowledge. So it's 90%. That means that we're less than 1.28 because this follows a z, a standard normal, same as this. So now we start rearranging. We start solving for y in this probability. So we subtract over this piece. We square it to get rid of the 1/2 here. And that's where we are here. Now we need to divide by 2, and that comes over here. And it said when n is equal to 41, so we plug in 41 to n. We start solving that, and then that reduces to this. And remember, this is the probability that this is less, is equal to 90%. So this is 52.8 is the 90th percentile of y based upon the approximation by Fisher. Number 47, let x1, x2 through xn be a random sample of size 11 from a normal distribution with unknown mean mu and unknown variance sigma squared, which is greater than 0. If the sum of the xi are equal to 132 and the sum of xi minus x bar squared equal to 99, then for what value of k is this interval a 90% confidence interval for mu? So number 47, we want to find the confidence interval. So a 90% confidence interval is this, and that's when the mean and the variance are unknown. So we use the t distribution, the sample variance and the sample size, and it's n minus 1, so it's 10, and then we start plugging in information that we know. The x bar is this, t is still that. Now the sample variance is this, and now we're given information. We're given this and given this, so we plug it in, and then that reduces to 12 plus or minus 1.8 square root of 0.9, and then that's the piece that we were needing. Number 48, if x has a normal distribution with mean 1 and variance 4, then the probability that x squared minus 2x is less than 8 is equal to what? Number 48, we're asked to find the probability that x squared minus 2x less than 8. And so here I take the 8 over. And if we were to graph this, it looks like this. So where is this function negative? It's negative between minus 2 and 4. So we really need to find the probability that x is between minus 2 and 4. but we're going to show that algebraically. So we have this, and then this factors into this, and then the only way that this is less than 0 is that one of these is positive and one is negative, and that only occurs between -2 and 4, which is what our graph indicates. So now here, since x is a normal distribution, we can subtract the mean divided by the standard deviation. It gives us a variance of 4, so the standard deviation is 2, and then solve those and we get this. And then on the table I have, you have to look up the probability of being less than 3.2 and then subtract the probability of being less than -3/2, which is this, which is 0.86. Number 49, let x and y be random samples, random variables with variance of x equal to 4 and the variance of y equal to 9 and the variance of x minus y equal to 16. What is the covariance of x and y? Now number 49, we want to find the covariance of x and y. So if we're looking at the variance of x minus y, that can be written as the variance of x plus the variance of y minus 2 times the covariance of x and y. And well, we're given this, and we're given the variance of x, and we're given the variance of this difference, and then we can solve that for the covariance of x and y, which is equal to 3/2. Number 50, let x1, x2 through xn be the order statistics from a random sample of size 6 from a distribution with density f of x equal to 2x. What is the expected value of x to the 6th? That's the 6th order statistic. Problem number 50, we're wanting to find the expected value of the 6th order statistic, or it's the largest order statistic. Here's our density. We find the cumulative distribution function by integrating from 0 to x of 2x dx. Ends up being this and equals x squared. So again, this is the formula for the largest order statistic, and this is one of those things that you're just going to have to know and memorize on test day. And once you figure out how to find the joint distribution or the distribution of an order statistic, it's very easy and straightforward. So we have 6 times the CDF raised to the 5th times the density, and then we plug in those informations that we have, and we get 12 y to the 6th raised to the 11th. So the expected value is you stick in a y to the 6th in this density, and that's why it becomes y6 to the 12th and raised to the 12th. And then when you integrate that, you get 12/13 y to the 13th, and you integrate from 0 to 1, and it falls out and becomes 12/13. Hope you enjoyed it. If you did, please like the video and subscribe so you don't miss the next one. Thanks. Bye.